All right, welcome folks. I want to describe one math fact that we're going to use when we partially verify that in this RSA crypto system, when Amazon decrypts, as I described in the prior video, they in fact recover your secret message X, which might have been your credit card number. Okay, so let's go into this fact. It's just a factoring trick. And it says if A is an integer, maybe I even just want positive integer. Sure, let's say if A is a positive integer, then A minus 1 divides evenly into A to the n minus 1 for any positive integer n. And the way I'm going to convince you of this is I'm just going to show you what the quotient is. Is that the right word? I'm going to show you what you get as the answer when you divide A to the n minus 1 by A minus 1. Okay, so in fact, when you do this division, you get an integer, which is equal to A to the n minus 1 plus A to the n minus 2 plus dot, 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 all the way down to plus A squared plus A plus 1. Okay. And let's, maybe sketch the proof. Let's just take A minus 1 and multiply it by A to the n minus 1 plus A to the n minus 2 plus dot, 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 all the way down to A squared plus A plus 1. So when I multiply this out, first I get A to the n, and then I get minus A to the n minus 1. Okay. Next, I get A to the n minus 1 minus A to the n minus 2. And then hidden right here is an A to the n minus 3. So when I multiply that by A, I get plus A to the n minus 2. And then when I multiply that A to the n minus 3 by negative 1, I just get minus A to the n minus 3. And this continues, plus, minus, plus, minus. Down near the end, I have a, let's pretend we're all the way down here. I have a plus A squared. And then I have a minus A. And then I have a plus A. And then I have a minus 1. And then the beautiful thing is that in the sum, everything cancels except the first and last term. So this A to the n minus 1 cancels with this plus. This negative A to the n minus 1 cancels with this plus A to the n minus 1. And this negative A to the n minus 2 cancels with this plus A to the n minus 2. And there's a hidden plus A to the n minus 3 that cancels right there. And there's a hidden minus A squared that cancels there. And then, okay, this minus A cancels with this plus A. And I just get A to the n minus 1. So I've shown that A minus 1 divides evenly into A to the n minus 1 because I've written down for you what the integer is that you get when you do this long division. And we'll use this when we verify to a limited degree 2 videos from now why the RSA decryption actually works to recover your secret message. Any public questions? Thanks so much.